Welcome. We're continuing factorizing. We're going to factorize quadratic expressions. What is a quadratic expression? It is an expression in this shape. Ax squared, the squared bit is what makes it quadratic, plus bx plus c. X is the variable. A, b, and c are numbers. A is a number. B is a number, C is a number, but for A, we have to say A cannot be equal to 0, because as soon as A is equal to 0, there is no x squared, and it'll just be x multiplied by a number or not, plus maybe another number. That's not a quadratic expression. The x squared bit is what makes it quadratic, and so we need this a to be anything but 0. Yes? To show you how factorizing quadratic expressions is the opposite, again, of expanding, let me take this expression, expand it, and then show you that factorizing is doing the inverse. The way we would expand this is to, some people remember FOIL, first, outside, inside, last. We multiply the first, x times x, the outside, x times 5, so plus 5x, the inside, plus 3x, and the last, 3 times 5 is 15. Then these two are like terms, so we can combine them. 5x plus 3x is 8x plus 15. This, as you can see, is a quadratic expression. It's, in this case, a is 1, b is 8 plus 8, c is 15, right? This is a quadratic expression. Now, if you're asked to factorize a quadratic expression, you're being asked to turn this trinomial, sometimes it's a binomial, you can imagine if either b or c is 0, then it'll be a binomial, is to turn this quadratic expression back into the product of factors. See how this is the product of factors? This is a factor, that's a factor. All that's happening is that these two are multiplied together. This is a product of factors. So going from a quadratic expression to the product of factors is called factorizing. Yes? All right, if this is a quadratic expression, then to factorize, you need to find two numbers that multiply to give c, whatever c is in your expression, and that also add to give b, whatever b is in your expression. So two numbers that both multiply to give c and also add to give b. Let's do a simple one. X squared plus 7x plus 10. All right. The x squared we got from multiplying the firsts, x times x, x squared, right? Now we're going to look for two numbers that multiply to give 10 and add up to give 7. We start by finding factors of 10. Which two numbers multiply to give 10? Well, 1 times 10, 2 times 5, but also -1 times -10, -2 times -5. Yes, I got all of them. Now we're going to look for a combination of two factors that add up to plus 7. Which of these add up to plus 7? 2 and 5. Positive 2, positive 5, positive 2, positive 5. And that is our answer. If we were to expand this, do FOIL, x times x plus 2x plus 5x, which is going to equal 7x, plus 10, we can see that that's correct. This is the factorized answer. Yep. Sometimes your quadratic expression has a common factor in the three terms. You may think, oh, this is going to be nasty because I'm going to have 2x in one of the parentheses. But as you can see, there's a common factor of 2 in here that you need to pull out first, factor out. Each of these three terms is divisible by 2, so let me rewrite it. It's going to be 2 times x squared minus this divided by 2 is 4x minus 5. Negative 10 divided by 2 is negative 5. And then this bit is just like a simpler quadratic expression, right? We're going to do 2 times this thing, but factorized, right? X squared came from x times x. Now I'm going to look for factors of negative 5. Let me write those down. Negative 5. We could have gotten that by doing 1 times negative 5 or negative 1 times 5. Which of these two add up to give negative 4? 1 plus negative 5 is negative 4. So this is the one. Let me just check. If I add these two up, I'm going to have a positive 4, right? So I want this plus 1, negative 5. Be sure to use these, right? Because the 2 is a factor that was pulled out of the entire thing. So we're going to have to multiply the entire thing by 2. Yes? Something else you can run into, the quadratic expression where the a value is greater than 1. Just to remind you, a is the number in front of the x squared, right? When a is greater than 1, which is the case here, it's 3. It's going to be a little more difficult. We can see that there's no common factor, right? There's no common factor. No, we can't divide these all by 3. Too bad. So we know that 3x squared came from 3x times x. That's the only way, right? Now we're going to do what we always do. Find the factors of plus 8. We could have gotten 8 by multiplying 1 and 8, or 2 and 4, or negative 1, negative 8, or negative 2 and negative 4. Now, we can try to plug in all these different combinations, because we can no longer say these two numbers need to add up to negative 10, because we know that one of the two numbers is going to be multiplied by 3. See that? So how do we get negative 10? I see something in my book that is really confusing me. I love it. The book gives me a wrong. Ugh. Okay, sorry. This should be a negative. Oh, sorry, guys. Okay, so how do I get negative 8? It would be 1 times negative 8, 2 times negative 4, or negative 1 times positive 8, or negative 2 times positive 4. we can fix this. Okay, so I'm looking for a combination of these, a combination of two numbers where one of the two is going to be multiplied by 3, and then they'll add up to negative 10. So it's going to add up to negative. So if let's look at this one. And I could try to plug all of them in and show you that there is one answer. But let me just look here. If I multiply this negative 4 by 3, it'll be negative 12, right? And then negative 12 and positive 2 will add up to negative 10. So now I need to make sure that I place my negative 4 so that it combines with the 3x. So remember, FOIL, first, outer, inner. So this one gets multiplied by 3x. So here I want my negative 4. So that the negative 4 gets multiplied by 3x to give negative 12x. I'm going to put my positive 2 in there. Now, because this one is a little trickier, I'm definitely going to check my answer by expanding, right? Expanding. First, 3x squared, outer, minus 4 times 3x, that's going to be negative 12x, inner, plus 2x, last, negative 8. The negative 12x and plus 2x combine to give negative 10x, and this is my original expression. So here is my answer. Okay, sorry, that was a little difficult for a bit. Then you'll remember the difference of squares. When your quadratic expression is x squared minus a number that is a square, then factorizing it would be x plus the number times x minus the number. And the number here is the square root of this, right? Let's do an example. If we're asked to factorize x squared minus 81, I notice that this is a square number, and x squared, of course, is square as well. According to this definition, a squared is my 81, right? The answer should be x plus the square root of 81 is 9. 9 times 9 is 81, times x minus 9. And let me just expand that to see. I'm going to put my box around it because I'm totally sure. Let me expand it to see if that was correct. Expand it first. X squared. Outer. Oops. Outer. Minus 9x. Inner. Plus 9x. Last. Plus 9 times negative 9 is negative 81. These two cancel each other out, right? Negative 9x plus 9x is nothing. I'm left with this, which was my original expression. All right, that was a quick refresher.